All right, and let's just take a look at where we are today. Whoops, get on to the right year. We are on November 7th. Okay, so today we're going to be talking about importing data from a database. So today we'll be introducing kind of the whole idea behind how relational database management works. We'll see how we can use both Excel, the kind of the out-of-the-box tools, plus VBA to consume data from a relational database. Next time we get together, we'll see how we can use VBA to modify data in a relational database. And that's one of the great things that we can do with Excel. So this first link here is just going to be a slideshow that we're going to kind of go through here, and then we'll have a file to download. And so to kind of have the background for what we're going to do today, we have to really understand how relational databases are managed. And the central thing, the key thing in a database management system is managing the data. So we've got data and we want to be able to keep track of that and control that to make sure that people who aren't supposed to have access to it don't get access to it. Make sure that if we have some kind of catastrophic hardware failure, that the data never becomes corrupted. And it's all about protecting the data. And the software that does that is referred to as a database engine. Who can tell me the name of a popular database engine? There's a handful of them that are really popular out there. Okay, so Microsoft has a product called SQL Server. That's the one that we're going to use in class today. And yeah, it is either the second or third in terms of sales volume, kind of right now, kind of depending on what year it is. What else is out there? Who's the biggest player? So Postgres and MySQL are two open source ones, and I'm not sure exactly how they measure up. When I'm saying I control the market share, I mean dollars spent. And because Postgres and MySQL are both open source, they have lots and lots and lots of huge installed base, but you don't pay for it. And so it's kind of tough to measure those. I'm not sure exactly kind of where they go in terms of installed server, probably more than SQL Server and even more than the biggest one, which is, oh, you're a different question. Go ahead. So Databricks, it's probably not relational. Now, kind of in the past, maybe 15 years or so, we've gotten a lot of database management systems that are non-relational. So they're called NoSQL databases. And Databricks, I'm not familiar with it, but I'm guessing it's a NoSQL or non-relational database. And the idea is still the same, but the approach is a little bit different. The idea with any database management system is we've got some software whose job is to manage the data. And we're not really concerned about displaying it to the user or how it's going to get consumed. That's going to be other software's job, but basically managing the data. Go ahead. Yeah, Oracle is the big one. It was really the first commercially successful relational database management system. And really up until about the year 2000 or so, in the world of business, if you said database, you meant relational database. It was really the only kind of database management that was out there and really being used in any significant way. And the idea behind a relational database management system is to say, listen, we've got one pot of data and we're going to have one piece of software to be able to manage that really, really well. And so what if we have, thousands of concurrent users? Then you get a bigger machine to run your one piece of software that's going to manage that data. And everyone else will connect into it and have that central repository. And this worked really great until we started needing databases that would work at web scale, to where you would say, no, I don't have thousands of concurrent users. I've got millions or maybe even billions of active users, maybe not all at the same time, but we're talking about huge numbers of users, and it's beyond the capability of any kind of one single hardware machine to deal with it. And that's when we started getting these other kind of databases that are more distributed. And you'd say, instead of getting a bigger machine to manage more users, you would get lots and lots and lots of computers to work together to kind of manage that data. But we're going to be talking today about working with relational database management systems. And database engine, then in the world of relational management, is in charge of data security, making sure that only the people that are allowed to access the data get access to it. Data integrity, making sure that when you say this customer or this sale belongs to customer number 25, there really is a customer number 25, so that the data itself is internally consistent. Data whoops, I missed a Y on that. Data recovery here, which means if we're right in the middle of updating data and lightning strikes and fries our hardware, we haven't lost any data. That's really important. Data definition, actually setting up the data to be able, the database to be able to hold data, to be able to bring data in, data manipulation, adding, removing, updating data. But the thing that it spends the vast majority of its time doing is running queries. So we've got this. So what the database engine does is it has direct, very fast access to the data, and it can crank through answering questions about that data all day long. So it does a little bit of the rest of this, but this is 90% of what a relational database management system does, is it answers questions about the data. But that software, the database engine, so MySQL, SQL Server, Oracle, Postgres, it's non-visual. There's no user interface that's a part of that software. Now, these companies, they write what we call front-end software that's meant to interact with the user. Have you seen this movie? So this is like Star Trek 4. I wonder if I can get to that. How do I get to that? Copy that link. It's a kind of a cute little clip that's just worth watching. It's about 20 seconds or so. So this is Star Trek 4, the Voyage Home, I think it's called. And in it, we've got the Star Trek comes back into the 1980s, the Starship, what is it called? The Enterprise comes back to the 1980s. And we've got Scotty here, the chief engineer from the Enterprise, is trying to make a deal with this guy to get a bunch of plexiglass to be able to make an aquarium. Don't worry about the reason, but that's what he's trying to do. And so he's getting ready to give him the formula for transparent aluminum in exchange for a bunch of plexiglass to make what he needs to be able to make. And he's going to show him how to make that now on his computer, which is like a Mac 2E or something. I'm not sure what it is, but it's the 1980s. And so we're kind of seeing then the user interface here. Of course, he expects to have a vocal interface. There's no vocal interface to computers in the early 1980s. So Dr. McCoy here is going to help him out. So he's going to use the keyboard. But the whole point here is that we're talking about the interface then between the user and the computer, and that then, or the information system, and that then is exactly what the front end application is responsible for. So whatever skills this user has, the front end application needs to be able to interact with the user to figure out what does the user want, and to be able to present the information to the user in a way that is understandable by that user. And so the front end application is responsible for displaying data, formatting data. How is it going to be aligned? How is it going to be sorted? Sorting can be kind of done both by the engine and by the front end. But the point is, it's basically presenting information to the user and figuring out what is it the user wants to be able to get so it can communicate that information to the engine. So two very different pieces of software, front end software and engine software, that work together to be able to meet the data needs of whatever the user or organization is. And so when we put these all together, then we say there's a front end application that works with the user. Once that front end application has figured out what the user wants, it's going to send a request over to the database engine. The database engine, and there may be like a network, in between here, right? This could be happening in a browser. This could be somewhere in a cloud server. But once the front end sends the request, it's told the database engine what the user wants. The database engine is going to check to make sure the user is authorized to be able to have access to it. And then it's going to try to do what the user asked for. So if they've asked for, maybe show me all the sales in the past 6 weeks that have ordered a printer that have not also ordered paper or something like that, some kind of question about our data, then the database engine will have direct access to that data, process the results to that, and then send the response back. So the response could be a set of records that meet the request, or it could be a message that said whatever you asked was completed. Like if you're saying change, insert a new record into the database, the message would come back and say, yeah, that was successful. Or it could be an error. You tried to do something, but it wasn't successful because it was malformed, or you weren't allowed to do it or something. And so it's then the responsibility of the front end application to present that information to the user. And so this is the background that we're dealing with as we think about how are we going to work with data, corporate data that's going to be stored in a relational database management system. And so now what we're going to see here is that the language that we're going to move data here across is going to be structured query language. How many of you say, you know what, I've got some familiarity with structured query language. Give me kind of 0 to 5 on where you are with structured query language. So I'm seeing 2s, 3s, 4s. I'm seeing an 8. On a scale of 1 to 5, I'm an 8 with structured query language. We've got a power user over here. And then 1, so some, and were there any zeros? I'm not sure if I saw any zeros up there. So folks, so there are a few of you who have no experience with this, and that's okay. So the idea here is that we are now going to use for our front end, we're going to use Excel as the front end. So the software that we're going to use to interface with the user is going to be Excel. And then for our back end, we're going to use Microsoft SQL Server for the example that we're running here in class today. And I think that's the point. So kind of high level, what we're doing with the data. Any questions here? All right, I probably should have given you a link for this as well, but let's do this. Let's just browse. Let's just browse to colonialbakehouse.com. Seems like when I set up a server, they gave me like a free domain name, and that was the best one I could come up with. If I knew I was going to be doing database stuff on this server, I would have probably named it something different. But this is just going to take us to a web front end where we can just kind of get a couple of practice runs in with running a particular query. And so we'll need a username and a password to get authenticated here. So let me just go ahead and bring up what that username and password should be. So you've got access with these credentials here. So for the user, redcat user at no quotes. And then for a password, capitalization will matter there. But we'll put in redcat user and then Thomas_1755. And that should authenticate us here. And what we're seeing with this interface is that this is just a web interface to a SQL Server backend. And so just sitting here in the browser, we've got enough information to like request data here. So I'll select star from redcat.customer. And now our browser now is interacting with the user, has collected the information that we're going to give it. In this case, the interface isn't allowing me to type the structured query language statement into it that the front end will send off to the server. The server then will process that and bring that back. And so here's the result. So this is a structured query language statement. So select says, it's actually the select statement where we're saying, I want to bring some data out of the database. The star means which columns do I want? And so if I don't want all the columns, I can give like a comma separated list of columns here. So instead of star, I'll say, no, I'm just interested in the first name, the last name, the street address, and the city. And so now we won't be showing postal code, customer ID, or phone number, or anything, but that'll just say, which columns I'm interested in. The from clause then says, which table do I want to pull the data out of? And this can get complex because I can join multiple tables together. That's beyond what we're going to do immediately here. There's also a where clause where I can say, I'm only interested in the ones from Utah. So where state is equal to, and then in single quotes, I'll put capital UT. And so now we'll recognize these as Utah cities: Brigham City, Bountiful, Springville, Roosevelt, Salt Lake, Brigham City, Logan, Tooele, and so forth. So that's the idea behind structured query language. It was meant, when it was invented by IBM in the 1970s, and it was meant to be a language that was so simple, even a manager could use it. That was the dream, to be able to have a language that managers could just come in and use and interact with the database themselves to pull the data out. We're not really to that point. So the language, ended up being pretty simple for simple questions, but as soon as you have to do something that's even a little bit complex, it's kind of beyond what you'd expect a manager to do. So we have kind of graphical user interfaces that managers might interact with, but it's not. SQL was meant to be language for managers to write in, but it really isn't. So it's usually more, it's the domain of more technical people like you. Okay, any questions on structured query language? So our task then is going to be able to get, maybe to run a query, maybe this very same query, and to be able to run this and bring the data in using Excel now as the front end. So I've downloaded a file. This first part that we're going to do isn't going to require VBA at all. So you could work in a blank workbook, or you could download the working file that we're going to use for our VBA today. That's where I am. But there are tools that are just built into Excel to be able to connect onto a relational database management system. And where am I going to find those tools? On the Data tab. So I'll come over here to the Data tab, and I'm going to choose Get Data right over here. From that drop down, I'll have several choices. And one of them is from a database. It should be no surprise that over here in Excel, the very top choice is Microsoft SQL Server. So this is this is Microsoft's kind of big iron database management, relational database management system. And so I'll go ahead and do this. And the truth is, the Mac version of Excel now has tools for connecting directly onto SQL Server. And in fact, they're even better than the Windows ones. As I look at them, I think they're even a little bit better than what we have on Windows. I don't remember them well enough to talk you through them, but you might be able to track it down on Windows if you're using the Windows version of Excel. So I'm going to go ahead and here and click on From SQL Server Database, and it's going to start asking me for a few things that we're going to need to know. So the first thing that we need to know here is what's the server that we're going to connect onto. And so this is going to be a host name or a database, host name or an IP address that will get us to the server that we are after. And so let me just pull up what we need to plug into here. And so that will just be colonialbakehouse.com. So it's running at the same domain as our web server was for the example that we did just moments ago, which I seem to have lost. Where did it go? Oh, here it is, remote query. So colonialbakehouse.com should be the name of our server. And then for the database, I'm going to type in REDCAT. So RedCat is just a sample database that I developed for a fictional shoe company that sells shoes online called RedCat Shoes. So the database is RedCat. So the server is going to get us to a particular instance of SQL Server, and that could have hundreds or even thousands of different databases on it. And so we're going to say, hey, we're going down to a particular database that we'll be looking at. What are our advanced options here? None that are going to be interesting to me. So I'm going to say OK. And I should be able to use those same credentials. So I'll bring those up again. Hopefully. So RedCat user and Thomas _1775. Now, SQL Server is wired to be able to use your Windows credentials, like whatever you logged into Windows to authenticate. Well, my server that's sitting up there in the cloud doesn't know anything about your Windows account. And so you don't have permissions with your Windows account. In fact, there's no Windows account that you can provide the credentials to that will be correct. And so I'm going to choose over here to say database. We're going to use an account that's built in and managed by SQL Server, not by Windows. And here's where I'll put in that username and password. So RedCat _user will be the username. And the password will be Thomas, capital T, Thomas _1775. And then I will connect. We were unable to connect the data source using an encrypted connection. To access using an unencrypted connection, say OK. OK, that's OK with me. All right. So hopefully we've gotten to this point, because once we see like these different tables that are in here, we've successfully connected to that database. Raise your hand if you connected to get to this far. Okay, so it looks like most of you. If you're getting an error message, If you're not getting that far, raise your hand and I'll come see if I can help see what the issue might be. Okay, so go ahead and go back. What Wi-Fi are you on? Jerome, that should be okay. Yeah, COLONIAL. Change that E to a. Change that to a. COLONIAL. Yeah, give that a shot. Yeah, it's redcat_user. And then capital T Thomas _1775. Yeah, that should be good. Say okay. Anyone else? All right. All right, so now here it's just saying, listen, which table do you want to connect on to? And in fact, let's see, one will be enough for us. I'm just going to choose the one called customer if I can find it. So here's customer. So it's previewing the data. That looks great. We have some other options here, like we could transform the data on the way in. I'm not going to worry about that. I'm just going to click on load. And that will then create, that will not just import the data, but this will create a query that is connected onto that data. So if this data were to change and I was to click here, refresh all, then it would make a separate request. It knows now the information to send the request off to that server and bring that information in. And so using absolutely no VBA at all, just built into Excel, we have the tools here then to just go and request data in. Let's see, what's this query tab do? What if I edit this? I'm not quite sure. Oh, this is going to open up Power Query and allow us to modify this. So there's other tools beyond just kind of the simple ones that are available on the data tab to bring data in. But once you get connected to the database, then you've got like several things for the interface of VBA that you can just pull data in. Questions here? Okay, so what we're after then is we're after seeing how can we do this like directly through VBA. So that's what we're after then for today. So let's take a look at the code then that comes along with this workbook. Okay, so there should be a single module with a single sub-procedure in it called DB1. And it's just got kind of the structure that we need to be able to have VBA reach out and talk to a relational database management system. The first thing to realize is that we're going to be using objects here. Now, these objects will be objects that are only available in the Windows version. So if you're on Mac, this part isn't going to work for you in class today. So very many of the objects that we worked with so far in Excel have been objects that are just created as a part of Excel. What are some objects that we've manipulated through code in Excel using VBA? Just throw out the name of an object or a kind of object. Anything we've manipulated through code. So an array is like not an object. Sorry, that's like it's just a bunch of variables together. Unfortunately, not an object, but so close. A worksheet is an object. What else? A cell is an object. A cell is just a range is an object. A workbook is an object. A chart is an object. A shape is an object, right? So, but all these objects are created by working with Excel. Like we could create a new chart, through Excel, and it's there. But because those objects are objects that are part of Excel, then Excel, like VBA, is like pre-wired to work with those objects. Working with a relational database management system is not something that out of the box VBA is like ready to do with Excel. So what we have to do is we have to tell it, listen, we're going to be working with a database management system. And so you're going to need to create the objects that we need to be able to interact with those, with that database. And so I think this is probably the first time we've done this in this class, but we're going to have to say, hey, we need some external libraries to be available for us to use in VBA. And here's how we do it. That's what this comment is right here. So to be able to make this code work, we have to make a reference to the ADODB library. It stands for Active Data Object Database Library. And here's how you do it. Tools, references, and then you find Microsoft ActiveX Data Access Object Library. Whew. So tools, references, and then we're going to find the Microsoft, what was it? Microsoft ActiveX Data Objects Library. I'm going to scroll down to where the M's are. Microsoft ActiveX Data Objects Library. And we got lots of versions, 2.0, 2.1, 2.5, 2.6. And the truth is, any of those would work for what we're doing, but I'm going to use the most recent one that I have on this machine, which is 6.1. And I'm going to check the little checkbox to the left of it. Clicking it is not enough. I have to check the box to say, yeah, I want to essentially import that code into my project. So whatever it takes, like the code that it takes to interact with these database objects, we're now going to make that available to us to invoke from VBA. We don't have to do this for the other objects that we manipulate in Excel. It's because VBA for Excel is like, we're expecting you to work with charts. We're expecting you to work with worksheets and workbooks. We're not expecting you to work with a database. We're making it available to you, but that's something that we're not going to load everything in the off chance you might do it. And so this is going to be something that we have to go through this extra step to say, make this available. Once I've made this reference in this workbook, that reference is going to stick. It's going to be around. I don't have to do it again. But each time I make a new workbook and I want to get access, my code to be able to work with a database, I've got to go and add that reference, which is why I've given the instructions to you here in the comment. So now we'll say, okay, and that's really going to give us access to create variables of this kind of object. So we've got a couple of string variables here. CS is just short for connection string. It's just a string variable, but CS is just the information that we need to be able to get connected onto the database. And you'll recognize this is the same information that we had to type in to be able to get to import the data that we imported through Excel. We had to get to the database, or we had to get to the server to the database, and it was a SQL Server connection. So we chose from database SQL Server, and then we gave it a database, and we gave it we gave it a host, database host, and we gave it a database, a server and a database. Well, we're doing that exact same thing here through code, and that's all in this connection string. And so the connection string says, hey, which driver are we going to use? We're going to use the Microsoft SQL Server driver. That was the first choice that we said, like bring data from a database. We're going to do it with SQL Server. Here then is the server that we're going to use, Colonial Bakehouse, and the database that we're going to use is Redcat, right? So on that server, Colonial Bakehouse, there could be dozens of different databases. We want the one named Redcat. And so the connection string is just a string of text that tells the database, these database objects, how are we going to try to connect? And these database objects, like this ADODB connection object, then knows what to do with that connection string. Like that information it gave it is like, great, we're going to use that to connect onto the database. Now, the reason we're using SQL Server here is because SQL Server, the driver for SQL Server, the software that knows how to speak SQL Server's lingo, be able to talk to the SQL Server engine, comes installed on Windows by default. But what if you were needing to talk to a MySQL database? Well, then you would need to install the MySQL driver. So for example, I'm going to look for the MySQL ODBC driver. Download the connector for ODBC for MySQL. So ODBC stands for Open Database Connectivity. It's like a standard for allowing different front ends to work with different back ends. You probably won't be surprised to find out that the driver for MySQL is free. We can do the same thing for Postgres. SQL. So Postgres ODBC driver, it's here and it's free. Just download it and install it. What do you think? Do you think the Oracle driver is free? The Oracle driver is free. There are some ODBC drivers that you will pay for. The only one that I know of is there's actually an ODBC driver for QuickBooks. Have you heard of it? QuickBooks, right? So it's like, small business accounting software. Well, if you want to access your data that you have stored in QuickBooks, like just through a database connection, I want to go and kind of query all my vendor files or all my transaction files, then Intuit doesn't give you that driver because they're like, wow, that's like kind of extra functionality beyond what we normally expect folks to use with QuickBooks. So they'll sell it to you, and that driver might cost you more than QuickBooks cost you to be able to get the data through that way. But it is a standard way to be able to connect an arbitrary front end to a relational database back end. And so almost everyone who's doing relational database management has some way for you to be able to get to them through an ODBC connection. And it's kind of a straightforward installation. We're using SQL Server because I know it's already installed on your Windows machines. Question? Oh, good question. So is there one for like SAP? Now, all of your large ERP systems, they are actually going to be hosted on kind of large relational database management. So we will run SAP quite often on Oracle. And so you don't really need a driver for SAP. You need a driver for Oracle because that's where the data is going to be stored. So the SAP, I don't know what HANA is. Anyone know what SAP HANA is? But apparently they have an ODBC driver for that as well. So, but let's see, ODBC driver for SAP. So this is C data. That may or may not be a helpful link there at all. But the idea here is that, so the interesting thing about the ODBC driver for a piece of software like QuickBooks is that QuickBooks is not a relational database management system, right? So like Oracle, MySQL, SQL Server, these are all meant for managing data in the database approach where you say we've got a front end, we've got back end software managing that. That is not what QuickBooks ever was. But Intuit said, wouldn't it be great if we could give people access to their data in the same way that they would through ODBC? So they wrote an ODBC driver to be able to have that kind of connection. So yeah, so the point is your ERP systems are really running on top of powerful relational database management systems. And so to get access to it, you don't need a special driver for SAP or PeopleSoft. I'm trying to think of what other, for Microsoft Dynamics, right? What you need is you need the driver for the underlying database management system that's managing that data. Most likely going to be SQL Server on a Microsoft product. But typically, at least the way that ERPs used to work 20 years ago when I was kind of playing with them, is you could kind of pick and choose your backend. So you could say, oh, we want to run SAP here. Well, what database do you want to run it on? You could run it on IBM's DB2 or Oracle or SQL Server. Those are your main choices back in the day. So whether Microsoft Dynamics lets you run on top of Oracle or not, I don't know. But the point is, wherever it's running, get the connection to that relational database management system and you can query the data directly. Other questions? So we don't have to go through that first step of installing the driver because we're using a database that you already have the driver installed for. Okay, and so with that connection string, that tells our connection object. So we have an object here called CN that is an active data object database connection object. Remember, it's an object, so it's going to have methods and properties, and one of its methods is called open. I'm going to give that open method 3 arguments. The first one is a string to tell it how to connect onto the database I'm interested in. So it gives it enough information. Use the SQL Server driver, connect onto this host, and use this database. And then we're also giving it a username and a password to become authenticated. Now, our other string here is just a structured query language string, and it's select star from redhat.customer. So here, this is the database, the same database we're using here. That's the default. We're specifying it here. We may not need to specify it. We'll play with that once we get it running. And then this should just bring back the records from the customer table. And then I'm going to use this object, the record set object, which is another object that knows how to deal with a whole set of records. And so it will then use a particular connection, execute a structured query language statement against it, and then allow me to manage those records that come back from it. One of the problems here is that these databases can hold tremendous amounts of data. And so what's not going to happen here is that this record set object is not going to say, hey, run that query and bring me back all the data. The reason? It quite possibly is going to be more data than you can fit into memory on your machine. And so what the record set object does is it says, it knows how to talk to the server and say, hey, server, run this query over there. And then I will ask for the records one at a time. So rather than all the records coming down at once, the record set object allows us to deal with those records one at a time. And that's going to be nice. So I'm just going to go ahead and put a stop here, and I'll run my code. Now that I've added the reference to this, I think this should work. And so as long as I get to that stop without having an error, we'll know that we got connected to that database. Or we might have an error right here, invalid object name redcat.customer, CUSTOMER. Okay, so we got connected. So we didn't have an error here, but when I tried to execute this, it didn't like it. CUSTOMER, that looks pretty good. I'm just going to pop back over to my web interface, if I can find it, and just try to run that query right here, because that's the same connection that we're making. Okay, so it likes that okay. But when I run it here, the error I get is it's coming back from SQL Server, invalid object name redcat.customer, CUSTOMER. So I'm just going to take off the database name or the schema name and try to run that again. It doesn't like me specifying the redcat dot in front of that. So I've just gone down to select star from customer, and that seems to get me to the data I'm after okay. And I'm not quite sure why. It seems like it should, I think it should allow me to put the database name in front of it. Oh, database is redcat. Yeah, I'm not entirely positive. Okay. Anyone get an error that's keeping them from getting to the stop statement here? If you're making it to the stop statement, raise your hand and show me that your code's working. Okay, good. All right, so now I got to decide what am I going to do to actually look at these. And so let's just kind of take a look at this record set object. So RS has a collection called fields. And so my record set has one record active at a time. And so I can now ask for a particular one of these fields. I can ask it, it's a collection. And as many collections are, I can either ask for it by its ordinal position or by its name. Well, fields have names. And so I should be able to ask for like the first name. I've got a first name field. How is it? Just first name. Yeah, no underscore. Case probably doesn't matter. And then I can ask for the value of that. And so that, print that, that should show me the first name of the one record that is currently active in my record set object. The record set object holds one record at a time. So that's James, probably the same James that we have here. If I was to look at last name, I should see Dominic. If I could type. Now, I could also ask for, instead of the value of that field, we can do it this way. I could ask for this by number. It's going to be 0 based. So 0 should be the user, the customer ID. 1 should be the first name. 2 should be the next name, because they're just in the same order that they appear here when I ask for those fields. So I can ask for the value, or I can ask for the name of that field. So what's the name of field number 2? It's the last name field. So what I'd like to be able to do with my code here is I would like to be able to say, let's go ahead and bring this data into onto a worksheet. So what worksheet do I have active at the moment? We've got sheet 1 active, and we'll just put this onto the active worksheet. So now that I've got this connection open, I would like to say, whatever cell that we're starting in, active cell, dot offset, I'm going to say 0 rows and 0 columns. That's that is the active cell. You'll see why I want to put the offset in there in just a moment. I want to say the value of that cell is equal to whatever the name of the first field is. That's going to put the name of that number 0 field. I want to offset 1 row or 1 column and put the first field, the number 1 field, offset 2 columns and put the number 2 field. So I'm headed towards making a loop, but realize I'm just calling a particular method of a particular collection of my record set object. So if I was to go and run these 3 lines, I'm starting over here in A1, it should put the names of those columns there, right? The same thing that I got back when I used the built-in tool to do it. We're kind of going to duplicate this functionality with VBA, just so we can kind of see how the VBA part of this works. So if I was going to do that with a loop, what would I want? Probably a for next loop. So I'll need a control variable, dim x as an integer. I'll take my 3-line example there and now make it into a loop. For x equals 0 to the upper boundary. Let's see, probably a count. It's going to be a collection, so I should be able to have a count property of it. To rsfields.count. Put next in here to increment x. And now, just where I have that vector 0, 1, 2, I'm just going to replace both of those with x. So now that will say, I don't care how many fields there are, just give me the names of the fields right there across, from whatever the active cell is, give me the names of the fields. I'll just go ahead and run that loop, putting myself back on A1 as my active cell. And I should see that put in then all of those. Cannot, oh, that's because it's 0 based. And so the count is going to take me where? It's going to take me 1 too many. So count minus 1. Try that again. And there we go. So that runs through and brings in the names of the columns. Whew. Well, let's just do this. We copy this loop. And here we're going to put the name, we're going to put the values. So now we're going to offset one row for my active cell. And we're not going to put the name of the field, we're going to put the value of the field. So it's a very similar loop. We're offsetting one row and then, whichever column, but now we're plugging in the value. And again, this is just that first row. So now we've got the information for the first row. So we just got to make this happen over and over and over again. And for that, we're going to use a do loop. And I think I'm going to want another variable. So let me declare R as a long integer. And then just before this loop, I'm going to set R to 1 because I'm offsetting from my active cell. And so the first time through, I'll want to offset one row. The next time through, I'll want to offset 2 rows. And so I'm going to change this 1 here to be R. But now I want this, which brings in the information for 1 row. I want this to happen over and over again. So I'm going to do a do loop. I'm going to wrap a do loop around this. Now, that's an endless loop. So we got to figure out some way to get out of this. So before we get to loop, I'm going to tell the record set to get the next record. My record set object right now holds 1 record. When I execute a query with that record set object, it brings back the first record into its record buffer. And now I want to tell it to get the next one. Here's how I do it. rs.move next. And you'll see that there's like these several move methods. So move to the first record, to the last record, to the next record, to the previous record. And we want to move to the next record. And now we are going to, in fact, we will do this. I'll put the exit condition up here on do just in case it brings back a record set with no records in it. I'm going to do until rs dot, and then it has a property called EOF. EOF stands for end of file. It's not really a very good name because it's not a file, it's a table that we're iterating across. But EOF was kind of a standard abbreviation for meaning you're at the end of the data. And so that will be a Boolean value, either true or false. And it's going to be false until we try to read past the end of the data. If we run a query that brings back no records, it will be end of file will be true at the very beginning. So before we ever try to print any of that data, it would cause us to bypass this loop because we're doing it at the top of the loop. So now if I come back here, do until until. So if I bring my active statement indicator back up to where I'm establishing R to be 1, this should bring in all of the 4,000 some odd customers from that. What did I forget to do? I forgot to increment R. So let's increment R in here. It brought them all in, but it put them all on the second row. So I'm going to go ahead and run that again, set R back to 1. Until rs, but I've been moved to the end of file. So I'm going to stop. So I'm skipping this loop because I already am at the end of file. So I probably can just tell it to move first. Let's just try that. rs.move first. And then we'll run this again. Duplicated this first record. I'm gonna have to figure out why that happened. So this move first, I just ran to tell that record set to go back to the beginning. If that's not working for you and you've got this typed in, just stop the code. I'm gonna clear this out and we'll run this code again. And that's running wherever I had the active cell, which was not A1. So put it back to A1. So that looks like that's working okay. It probably duplicated that first record because when I ran it the second time, I was probably on row 2 instead of row 1 when it was doing the offsetting. Questions? So why did we take the effort to go through and just duplicate the functionality that was already built into Excel? And the answer is that so we can see the data that we're looking at, but it may very well be that you don't really want to ever put that to a worksheet. Right? So you got some procedure that says, go and get this data, and then my code is going to do something very different with it. In other words, I could run the query, bring the data back, process that in VBA, and never, ever send the data out to a worksheet. But let's look at a couple other things. The next thing I'd like to do with this example is I would like to go ahead and make it into a table. I don't think we've made anything into a table yet in this class. It's pretty simple to do. I can never remember the code, so I'm going to record myself doing it. So if memory serves, this code is simple enough that you might just watch me do this and then type the code that it generates. Or you can follow along with me. So I'm just going to come and record myself. So developer tab, record macro, call it macro 1. That's great. And I'm just going to select somewhere in my data and choose insert table. So that should convert this range into a table that's going to kind of give me some nice coloring, give me tools to filter and sort here at the top and so forth. And I'd kind of like that to happen as a part of my code that's bringing that data in. So I'm going to go ahead and stop recording and go take a look at the code that just got generated. So in module 2, here it is, list objects.add. And then I'll just bring that code back to module 1. So after I've brought that data in, instead of stop, I will say active sheet.listObjects.add. Excel source range, that looks good. For my range here, I'm going to put active cell, because we're doing everything based off the active cell, dot current region. So the whole set of contiguous data that I just brought in, I'm not sure what we're skipping there. Let's see if it'll tell us. Nope. And it's naming that table 2. I don't think I really care. I think if I don't name it, it will probably just give it an arbitrary name. So I'm going to get rid of that, but realize that because I'm doing something with the reference to the list that this thing returns, that's why I have to have these parentheses around the argument list. So I'm not going to do anything with what it returns, which means I also need to get rid of the parentheses. So now if I add a new sheet and run this code, A-C-T-I-V-E, A-C-T-I-V-E. Oh, somehow instead of adding 1 row each time, I got to add 16 rows. So let's go and reset that. And so now that brings the code in, or brings the data in and makes it into a table, which also has the nice effect of resizing the columns to match the data widths that we have. Questions? Yes. Oh, it's not resizing that last one. You know, I think mine isn't either. How interesting. I wonder why that is. Oh, is it just resizing based on the header? Ah, that makes sense. Well, we could resize it for the data. It's called auto fit. So I'll just do the same thing here. I'm just going to say active cell dot current region dot auto fit. I'm not entirely sure we want to do that because we might have like one city that's got a really long name. But let's run that and see what we get. Make a new sheet, run the code. Active cell dot current region. Oh, I think I have to say dot entire column. That's not too bad. Some addresses are longer than others. But so the auto fit is going to give us then actually make that fit. Other questions? Now let's just see how long that takes. I wonder if it's going to take longer than a second. I don't know. Let's do this. I'm going to kind of at the very top of this code, I'm going to print the current time in OW. And then I'm also going to print the current time at the very end. We may have to get to a bigger data set to be able to see that take longer than a second. But I'll run this and it should. Yeah, so that happened within the same second. So I know that we've got a bigger data set out there. It's not much bigger, but instead of customer, let me select star from sale. I think there's like 12,000 sale records. And I think just for, I kind of like this the way it is. This will run on whichever cell I have active. But just for demonstration in class here, I'm going to go ahead and add a new sheet at the beginning of this so that when I run it, it'll just give me a new sheet to work with. So I'm just going to say worksheets.add. Even that, how many records is that bringing back? Oh, only 4,000. Oh, it's the line items. It's a sale item that's got like 12,000. So let's try that. Sale item. There we go. At least that one spanned a second. Let me run it again and see if it spans a second again. Yeah, so that's taking more than a second to bring that in. And the truth is that iterating across those record sets one at a time takes some time. Now, I'm processing 12,000 records in about a second. That doesn't seem too bad, but what if I'm processing a couple of million records? Well, I can't fit those into Excel. What if I'm processing, 1.04 million records, which I could fit in here? That's going to take a while to do it. Do you expect to work with databases, sets of data that have millions of records? Yeah, you should expect that. That's the whole reason that we have database management systems, is to manage lots of data. And thousands or even tens of thousands of records is not a lot of data by, in the realm of data management. So I'm going to show you a different way to pull records in if what you're trying to do is put them into a range. So I'm going to copy our DB1 statement, or our DB1 procedure, and we'll duplicate it, call it DB2, and we'll make some changes. This is all going to be the same right up to where we have R defined. I think I will, so just this part where we've got the loop that's going record by record through that record set, there's going to be a faster way for us to do this. So I'm going to delete all this part that deals with R and dealing with particular rows. I still am going to need to bring in the headers. So I've got this loop to bring in the names of the fields. But now what I want to say is active cell.offset. So active cell.offset, and now I want to say one row and no columns. So I can just leave, pass no argument for columns. So that'll be one row below the active cell. And you're going to find out that a range object has a method called copy from record set. And all I have to do is tell it the record set that I'm after. What's the name of my record set object? RS. So instead of going through these one record at a time, which I might need to do if I'm never putting them out to a worksheet. But if I do need to put it out to a worksheet, then copy from record set is going to happen considerably faster. So we'll run that one with F5. And I said considerably faster. Was that DB2? Yeah, we're not iterating it. And maybe it's not considerably faster anymore. It used to be considerably faster. A little bit faster. It's happening now within the same second. Yeah, I think that's a bit faster. Oh, okay. So yeah, so it's probably not the machine so much as it is the connection. So I'm on a really fast wired connection here. And so the difference in time is, instead of bringing one record at a time, it's managing that connection much better. It may not be bringing it all at once, but it's going to be bringing it in larger chunks. And that's all happening then and implemented inside that method, which, is a part of the range object. Where is it? Copy from record set. Yeah. So there's a method called copy from record set that a range is like wired to be able to bring data in from a record set. Questions here? So in terms of reading data from a database, that's the lay of the land. Now I want to do one more thing here, and that is to do a more complex structured query language statement. So if I was to look at select star from the sale table, what we'll see here is that this sale says, hey, this sale happened on a particular date, but who was the customer who actually made this sale? Well, it's customer 1134. So if I wanted to see who that customer was, I could say select star from customer. Where customer ID is equal to 1134. And so maybe I'll only look at sale with a sale ID of this. Right, this is what relational database management does. It says, listen, if I need to know information, I've got, where I say, each customer could have multiple sales. I don't want to duplicate that customer's information on each sale. I want to keep track of what the information about the customer is in one place, and then just kind of hook up to that record each time I have a sale. And so that's why we use a number to identify the customer rather than putting the whole customer information in here. So now I can see here's the sale information here. And then here is that customer number 34, right? So when I have a customer ID 34 here, that refers to that particular customer ID here. Well, one of the neat things about structured query language is that I can tell the query to make that join for me. So let's see how to do that join. We'll bring that into our code and we'll call it good for the day. So I'm going to select star from redcat.sale. Maybe I'll bring my from down here. Get rid of my where clause because I want it to bring it the information for all of them. I'll take all of my sales and join it to all of my to all the appropriate customers. So I'll say sale. Let me do one more thing here. I'm going to get rid of redcat here and tell it to use the redcat database here. I think that's why it's requiring me to use it here. I'm telling the connection to be redcat here. Let me just check and make sure that works. Yeah. That way I'll be able to just copy this query and bring it over. So the change I made here was I changed this from user data which is the default on this page, to red cat. So from sale, and I'm going to tell it to join customer on, and then I'm going to say, I'm going to tell it where the two columns are equal to each other. So where sales customer ID is equal to customer's customer ID. So where the two tables have the same value in that column. And that then should bring back the sale information, but then on that row, it's going to bring the customer information as well. So I've got a couple of sales here. They're to the same customer. We should be able to see that when I see the customer ID 12 from the sale information, I see that same customer ID 12 from the customer information, and it's merged it together onto the same row. This is a normal join. Nothing, it's like this is not advanced. This is just kind of normal select statement. And I'm going to go ahead and order this by the customer name. So order ORDER by last name, first name, sale date. Order by. Thank you. So now these should be alphabetical by last name. And first, if we have two customers with the same last name, whoever has the alphabetically short first name will come in first. So point is, now I can bring that whole query and just drop that into my code here for my SQL statement instead of select star from sale item. And VBA is going to like it better on one line. I could concatenate that together, but one line will work just fine. So I've just put that onto one line, and this now should bring in that data set. Must be editing a field. Took a second to do it, but brought in then that whole set of data. Should be, yeah, like 4,000 sales with all the customer information included. So that's the great thing about this, is that once we've got our structure set up, it's now just a matter of changing the structured query language to be able to tell it what to bring in. Okay, anything else here? On Thursday, class is dismissed because it's an MBA recruiting trip. So we will gather together again a week from today, and we will see how to modify data in a database using VBA. All right, thanks for coming. Class dismissed. Yes. Actually, just let me get this saved first. Just a quick question or code question?
Is there other question? I know what that shows. Here it's. It took so long. I think what it's saying is make the request to replace. That means it's not. You can on the so that you can get back to the page. How do you know it's it might be a value issue. It might be. So this happens on book 14. That's the workplace. So it may be that on a Citrix server, if you move to the server field, it may be that you're not able to route portions that you cut on the Citrix server. So if I were to do it on this machine. Let's see that you're really doing, not just spending something. Definitely talk about this. That way, in this problem that today is. Writes that communication to the file to itself. Yeah, I guess because it depends on what you see. So older children should only looks like they're working. Best shot. I'm just going to get plugged off here.